Hello, my name is Kristopher Turner. I'm a principal consultant at Invoke LLC here in Texas. Today, I'm going to talk to you about how to use Azure Site Recovery to save your bacon, your Christmas ham, or maybe even your job. Okay, so let's talk about disasters. Disasters don't come when we expect them to come. We don't schedule a flooded data center. We don't decide that today is the best time for our data center to catch on fire and burn down to the ground. We don't control the hurricanes, tornadoes, or earthquakes. These are all events that we can't control. However, there are events that we could plan for. So let's get this festive party started. So today I'm going to talk a little bit about who needs disaster recovery and what does good disaster recovery look like. And then, of course, the Christmas ham, we're going to talk about Azure Site Recovery and Azure Backup. And then at the end, we're going to discuss how to use some of these tools through the Windows Admin Center. So who needs disaster recovery? My number one answer is everyone needs a disaster recovery, especially for those people who want to keep their jobs. And what does good disaster recovery solutions look like? A lot of people think doing replica from one Hyper-V cluster to another Hyper-V cluster, or using simple solutions from one site to site is good disaster recovery. Even going from on-prem to Azure using Azure Site Recovery, some people think that's all they need. But they still need a good backup solution because even though you do have a site recovery solution that might go from, for instance, your VMware solution to Azure, how are you protecting those VMs when they get to Azure? So those are the things that you should kind of look at. We're not going to go really deep into what a good disaster recovery solution is, but my point here is not only do you need a good site recovery solution, but you also need a good backup solution on top of that as well. So my focus today is going to be on Azure Site Recovery. However, once you do get your solutions, your protected items replicated and synced, and you do have a failover to Azure, or you do have a failover from one site to another site, you still need to think about a good backup solution for those systems as well. And I will go a little bit into Azure Backup as we move forward, but my primary focus today is all going to be about Azure Site Recovery. So instead of boring you to death with PowerPoint, let's go ahead and just jump right into some demos here. And as I go and demo the solution, hopefully I can answer some more questions about Azure Site Recovery and some of the different solutions that it provides. So let's go ahead and jump right in here. Let's talk about Azure Site Recovery, what it is, and how we're going to set it up. I'll go over my little demo environment as well, and then we'll just move on forward and configure everything and have some fun today. So let's talk about my demo environment really fast. First of all, everything I have is going to be running off of Hyper-V on a server here I have at home. Basic Hyper-V server. I have 3 VMs that I'm going to basically protect today. One is a domain controller, one is a SQL server, and the other one is a front-end web server. Those 3 boxes I will replicate. I will enable protection on. And let's go over to my Azure environment here. In my Azure environment, I am going to create a few resource groups, or I have created a few resource groups. One resource group is going to be for my vault and storage account. Another resource group will be for my test over failure test, and then I will have resource groups that I have created to actually when we do a planned failover or when an unplanned failover, where those VMs will be will be dumped into. I'm also going to be creating a virtual network, one virtual network for the test failover. That way, it's in a bubble, and when we do a test failover, those VMs will not be able to communicate with other VMs within the same Azure subscription and region and things like that. We don't want them to talk back and forth when we're doing test failovers. Then we'll also have a virtual network that's already been created for my environment that the VMs that do get failed over during a planned failover or unplanned failover will take advantage of. And then, of course, we're going to create two vaults. One vault for the site recovery data, and then another vault later for our our backups that we're going to enable to make sure that our failed over VMs are being backed up and properly taken care of. As you can see in my little mess here, um, this is my nice little mess of demos and stuff. So I've created a recovery east and a recovery south central US. I'll be using the recovery south central US resource group for the demo later on, where we're going to actually do a plan failover. And I will also be using my my brains are dead. So let me find out. Sorry about that. Actually, my recovery South Central U.S. resource group is where my resources are that I've already pre-created, but that's where my recovery service vault's going to be, my backup vault's going to be, and the test VNet and things like that that I'm going to need in order to be able to do a test failover, and of course our storage count um, that the data replicates up to um, from on-prem into Azure before we do a failover. And then I will be using my Waco ASR South Central US resource group for the resource group where we're going to be doing our planned failovers as well. And those machines, when they are dumped in, we'll talk about a little later about networking and some of the importance that we need to plan ahead on. So let's go and talk about networking at a pretty high level here. It actually is going to be very important before you start doing anything with ASR to kind of architect this the correct way. For this demo, it's pretty simple. I'm uploading I'm going to be protecting three VMs. They're going to go to a storage account. I'm going to use a single VNet. And my VNet in my environment is a hub and spoke environment. But even with that, it's going to be pretty simple. It's going to be a single subnet for all three devices, and things like that you're going to have to start thinking about, because you're going to have to think about network security groups, and you might have different tiers where your applications have to be protected. Your back end, your middle, your front end, your database, and all that other stuff. But for me, it's going to be pretty much a flat network. It's going to be all the same subnet. The test VNet is going to be a 192 address. My demo VNet that's going to be simulating a real VNet is going to be a 10.1 address or something like that. I could go into that a little later. So things like that we need to that you really need to plan and discuss. Specifically, if you're going to need these applications still to communicate on-prem, if you have some kind of virtual network gateway going down, or just communicate with other applications in Azure. There's a lot of planning around networking that needs to be done. So you just can't jump into this and start doing ASR without planning that out as well. DNS and Active Directory is very important, something that we should talk about. For my environment, I do not have any domain controllers running as VMs in my environment. I do not have a virtual network gateway to my on-prem environment. So that's the whole point of me replicating a DNS server up in this demo environment, so I could have that capability to be able to authenticate these VMs still during testing purposes. But in most cases, most people already have some kind of Active Directory presence in Azure, usually running within some kind of VM, or they have an express route or a gateway that connects on-prem, so these physical machines could authenticate as well. I mentioned a little bit about IP addresses. That's something that we need to discuss a little more. That's going to be important. When you're replicating machines up to Azure, more than likely you're not going to be using the same IP address spaces. So what your IP addresses were on-prem versus what they're going to be in Azure are going to be slightly different. With ASR, we could change the IP addresses of the machines themselves when they come up, but there might have some information, some situations where you might have like a failover cluster, like a SQL Always On, or some kind of cluster where that cluster IP needs to change as well. So in those sense, that's when you want to bring in some kind of automation, like for instance, an Azure Automation Runbook that might run when you do failovers. Um, and then that Azure Automation Runbook will be designed to just specifically change specific IP addresses for you automatically without you having to go in and change them yourself. But my demo, it's like I said, it's a flat network. I have a 192.100 dot something network on-prem, and for the first test failover, I'm going to dump them into the same subnet. And then for the demo that we're going to actually do to simulate a planned failover, we will have ASR change the IP addresses statically on those to match the subnet in my address space in Azure. So let's talk about ASR really fast before we start getting in and actually showing how to create the things. So Azure Site Recovery, when you go into your Azure Recovery Service Vault, which let's pretend this hasn't been created yet, but it's here anyway. You can have various tools on the left side here, that various configurations that we're going to have to pay attention to. I'm going to be doing a Hyper-V to Azure and then Azure back down to Hyper-V solution. So we're going to come down over back to Manage, and we're going to go to Site Recovery Infrastructure first, and we're going to talk a little bit about some of the stuff here that we could use. We do have the support for System Center VMM, which is pretty nice if you're still a VMM shop. And of course, we have support for VMware and physical machines, which is actually really nice. And then, of course, Azure to Azure. And there's going to be a little bit of discussion toward the end of why you would sometimes use ASR from Azure to Azure. Actually, it's why it's actually needed as well. But today we're going to kind of stick basically to Hyper-V sites to Azure and then Azure to Hyper-V. We did have the capabilities of doing site-to-site, for instance, from VMM to another VMM, but that is going to be depreciated here shortly, so we won't go into discussions about that right now, since that's going to be gone soon. So what I'm focusing on today is the Hyper-V site. So we're going to have a Hyper-V site is basically just representative. It represents like a physical site, or could represent a physical site. So for instance here, I have a Hyper-V site called Dallas, DC. Right now there's no Hyper-V host included, and there's no protected VMs included in this site. Today we'll create a Hyper-V site for Waco, DC, and then we'll also set up our Hyper-V host and add them as Hyper-V host to that Hyper-V site. And then we're going to talk a little bit about replication policies as we go through as well. These are the three main areas that we're going to focus on a little bit here when the demos start. And then another important thing that we're going to talk about is our recovery plans. These recovery plans I will discuss a little further in the detail, but those are the areas that we're going to be talking mostly about here soon. In fact, instead of just talking about what we're going to talk about, why don't we just jump on into how to install the stuff and how to configure the stuff and how to actually protect your on-prem servers using Azure Site Recovery. So one thing that I did not bring up, at least I don't remember bringing it up, but I'm going to bring it up now anyway. As you can see here in my Recovery South Central US resource group that I have set up, I have a Bastion service configured. The reason why I do that is because, well, best practice, of course, your VMs should not have a public IP address. I know people do public IP addresses on VMs, but to be able to communicate to those VMs securely, I'll have a Bastion service set up. That way I don't have to present a public IP to my VMs. That's one thing I just wanted to call out really fast before we jump into this fun solution in this fun day. Okay, so let's create some stuff. But first, I also want to point out two things here. We have a recovery site service vault, and we have a backup vault here. For what we're going to be protecting today, everything is going to go inside that recovery service vault. The backup vault himself is specifically for Azure Disk and Azure Blob Storage, and then, of course, the Azure Database services. But everything else is going to fit into the recovery service vault. That's going to be your virtual machines, your Azure files, your backup server information, DPM, all the data sources from those solutions will go into that recovery service vault. Now, in the production environment, you're probably going to want to split out your service vaults, your vaults based off of your workloads. So, for instance, my ASR workloads, I would put in a separate service vault for my VM backups. But in this solution, this demo, I'm going to use the same vault, and then we kind of move forward from here. Okay, so it's fairly easy to create the recovery service vault here. I'll create one just for as a demo purpose, but then I'm going to continue using my recovery service vault that I've already created. Basically, just create the resource group as if you're going to properly have all these resources in the correct resource groups. In the marketplace, we're just going to do a quick search for backup and site recovery. Then we're going to come down to create backup site recovery. We're going to either leave it in the resource group that we just previously that we have already created, or we're going to create a new one. We can just create a new one. Demo vault RG. Merry Christmas. We'll click OK. The name of the vault, in this case, I'm just going to name it XYZ. Oh, X-ray, X, Y, I don't know. That's just demo vault. Just for this demo real fast. The region is going to be highly important. So where your vault's going to be located is where you're going to have your VMs that are going to be protected and failed over to. So if you're going to be using South Central US or some other region, it's going to be highly important that the storage count and the resource, the site recovery vault, is in the same region as where you're going to be recovering those filling over your VMs to. So if you mean to use Central US, but you put your recovery vault in East US, that's not going to work for you. At least at this time. So we're just going to go and just pick some location. Also, something to call out is make sure that you pick a region that your quotas, you won't run out of quotas. So let's say you're going to be doing a failover of 100 VMs with 2 CPUs, and your subscription for your quotas on that region only have 150 CPUs. You're going to run into the issue when you're trying to do some failovers. So make sure your regions and your quotas are set appropriate for that big of a workload to be dumped into. We just click review, or actually let's do our governance correctly, some kind of a tag, etc. And then we're going to review and create it. And it takes about 4 or 5 minutes for that site recovery vault to be created, and then we could continue on. So we've got our recovery vault created, and now it's time to kind of configure this recovery service vault to be able to protect our VMs on-prem. There's 2 ways we could start if you're doing this out of the box. Is we could come up here and enable site recovery, or we could come down over here to the site recovery infrastructure under manage. Both ways is good. One's more wizardy, the other one is more knowing what you're going to be doing. I'm going to go ahead and click on enable site recovery and walk you through the wizard, and then I'll kind of talk about the difference between the two here shortly. So on this screen here, we're going to come over to Hyper-V machines to Azure, and we're just going to hit prepare infrastructure. Under deployment planning complete, we're going to go and select yes, we've done it. Even if you select no, I'll do it later, it's going to let you continue. There's some good information to read on Microsoft Docs if you click here, or if you want to download the deployment planner and run it, which I would recommend you doing it if you're actually going to be doing this in outside of even as a POC. I would recommend you run that deployment planner. We're going to click next. We're not going to be using VMM. There's not much difference between, there is some slight differences between using VMM with ASR versus just Hyper-V Direct. Of course, you're going to be doing everything within the VMM console, but there's also a VMM provider that you need to install along with the agents that you're going to be installing on Hyper-V, on the Hyper-V host as well, just like we're going to be doing today. So we're going to hit no. Mentioned earlier, I showed you the Dallas, DC Hyper-V site. We're going to just create a new Hyper-V site here. We're going to call this Waco, DC. It's just basically a, and then once we're done, it takes maybe a few seconds. Oh, how the bar goes here. Half the time. And we'll wait for it a little longer here. Now we're done. We've successfully created our Hyper-V site called Waco DC. Now we need to add some Hyper-V servers. Using the wizard, we're going to be able to see that we're going to, first of all, we're going to make sure that they're at least 2012 R2 or higher. If there's any proxy configuration settings you need to worry about. Next, we're going to download the installer, the Microsoft Azure Site Recovery provider. This is the agent that we're going to be running on the Hyper-V servers. This is also the same agent that you run on the Hyper-V servers if you're using VMM. But with the VMM process, there's one more step, and that's to download the VMM provider as well. So let's go ahead and download the installer. Fairly easy, just click download. It's going to pop up. We're going to save as, and we're going to save it into a folder that we're going to use it. I've already pre-downloaded it to save some time. I'm on a very slow connection here, so I like to pre-download as much as I can. And then same thing, we're going to come over here and click download for the registration key. And we're going to download it to the same folder and basically just save as. And then I've already downloaded that too, so we don't need that at this point. So I'm going to switch over to my Hyper-V server where I have the file already on this box. And this is where we're going to install the site recovery provider for Hyper-V. And then I also need to bring over the recovery key as well. We're going to just kind of leave the defaults here. So Microsoft Updates can update the agent. We're going to leave default location. Okay, install. When this is done configuring the service, it should prompt us for that site recovery key that we created and that I secretly copy to the desktop while you guys are not looking. And just like that, a few seconds later, due to the magic of pausing videos, the site recovery provider has been installed. Now we're going to click register to register this device to the recovery vault that we previously created. That's going to be associated to this ASR key that we downloaded. So browse, we're going to go to the location where we have it located. Everything should look good. It's going to be Waco DC Hyper-V site. It's going to go to that vault name that we created. And this is our subscription. Everything looks good. We're going to click next. We're going to connect directly to the recovery, the Azure Site Recovery, without a proxy server. If you had a proxy server, this is where you would enter the proxy information. And now we just wait for it to connect. And it's going to do some certificate creation, and then it should register itself to the site recovery vault that we got created. And then in a few minutes, we should be able to continue on. Okay, now that the provider has been finished installing and it's now been registered, we can click on Finish. And then we'll go back over to our the Azure portal here. And this can take anywhere between 15 to 30 minutes for this Hyper-V server to show up in Azure. So I'm going to put this on pause, and I will be back in 1 second for you, 30 minutes for me. Before I do go, I wanted to point out we could have done this a different way, so we didn't have to wait for the wizard to complete and just sit here and wait for it to show up. Um, this won't hurt to go back. We've already registered everything. If we go back to our site recovery, our site services vault, we could have gone down to the site recovery infrastructure, and from here we could have added the second Hyper-V site, and then we could have added the Hyper-V host here, which actually is showing up magically fairly fast. We could have added the server here and then walked through the same process that we did, where we download the installer, um, tell it what site we want to create, and then it's going to give us a registration key to register it with. That would have been. This is going to be more for those who have multiple um, sites and multiple Hyper-V servers at their not multiple Hyper-V servers, but multiple Hyper-V servers at multiple sites, and you're going to be managing a lot larger infrastructure than just this demo. Okay, so we have our Hyper-V servers now connected and healthy. We have our Hyper-V sites created. We could either go back to the wizard and walk through the wizard, or we could continue from where we're at, where we start doing some things manually. Since I'm already here, I'm going to do one thing. I'm going to come down to retention policy, replication policies, and I'm just going to create a replication policy manually, and then I'll go back to the enable site recovery wizard, and we can walk through that and see how that works. So the replication policy is pretty simple. We're going to name the replication policy. For me, I'm just going to name it Waco to Azure Hyper-V, something simple that I'm going to be able to know what that policy is for. We're going to call it default because we're not going to. It's not going to be a policy that we're going to need to make sure that it's replicating data at a certain speeds. And we'll talk about that here. Actually, copy frequency it's called. So we're going to Hyper-V, and we're going to go to Azure. We could create another replication policy that goes Azure to Hyper-V, but for now we're going to do Hyper-V to Azure. The copy frequency is basically going to be how far the delta. So once the initial sync has been done and the chunk of your VM data has already been replicated to Azure into that storage count, then we're gonna specify this replication policy. So that VM on my Hyper-V server every 5 minutes will copy any delta changes. If you have a more critical application that needs to be copied over sooner than that, you might want to choose 30 seconds. But for this, we're going to be choosing 5 minutes. The recovery point retention hours default is 2. The maximum I think is 24. So if you do need to have a recovery point that's farther out than 2 hours, then you would probably want to change this to something more than 2. For the replication, we're going to immediately start replication when we start protecting these items. This one here doesn't really matter much for us, but I do want to call it out. If you were using VMM, you could actually edit this. And the way this works is everything is controlled in Azure. The way you create and assign these policies, what you protect, etc. You could come back down here and edit that to where you could do some of the same stuff from the VMM console as well. But out of default, everything is controlled from the console in Azure. We're going to go ahead and click OK. And that's going to create our first replication policy, and the only replication policy that we're going to need for this demo environment. So now we have our replication policy. Let's go back to the site recovery infrastructure and then back up over to the actual recovery service vault. And then we'll just kind of go through the wizard up here, and we're going to enable site recovery. Kind of the same stuff we did before. Yes, we've done that. No, it's on VMM. We're going to select Waco, and then we're going to have our Hyper-V server that now pops up. We're going to click Next. From here, we're going to make sure that we choose Resource Manager for post failover deployment model. The other one is Classic. We no longer use Classic, and it's not supported. At this point, if we didn't have any compatible source counts or networks, it would give us not a fancy blue fun check. It would give us throw us an error, and we wouldn't be able to continue. So let's go and click Next. And then this is the revocation policy that we're going to be using. We could go ahead and click Create New Policy if we wanted to, if we wanted to create a new policy on the fly, or if we had it actually created a revocation policy, we would create one here. But we already pre-created this policy. If you click on Next, it's going to throw us an error that this status, this Hyper-V site has not been associated with this revocation policy. So we're going to go ahead and just click Associate to this selected policy here. And then we're just going to click OK. This is going to associate that Hyper-V site with that policy. Okay, so now we successfully associated Waco DC to this replication policy. We're going to go ahead and click on Next. This is going to let's review, make sure that everything correct. Then we're going to click Prepare. And while it does its things in the background, I'm going to pause this for a second for you, a little longer for me. Okay, now we're ready to actually start enabling protection on our VMs. We could do one of two ways. We could go up here and enable site recovery, and then hit number 2, enable revocation, or we can come back over here to protected items, under revocated items, click the downward under revocate, and choose one, the proper targets. We're going to go ahead and hit Hyper-V machines to Azure. At this point, this screen here is going to be the same screen that you're going to see if you would have gone to the wizard. So there's not much difference in the way to get here. We're going to make sure we're going to select Waco DC as our source location. This is going to be the failover resource group that we're going to be using. This is the deployment module. We're going to be using Resource Manager, not Classic. We're going to pick the source count that I have specifically created for this site recovery demo. And the only ones that are going to be supported are going to show up in that thing. This here for network, we have two choices. We can configure these, the networking on these VMs later, or we can configure them now. For myself, it's all going to be the same. All these machines are going to be on the same network. And I don't want to go through each machine and click each machine and change them later. So I'm just going to configure them now. I'm going to use my VNet hub for now. And this is going to be for a configuration show when these machines are going to be doing a planned failover or unplanned failover. When we do a test failover, we'll target a different virtual network. The subnet I'm going to be using, I'm going to be popping them into my Waco prod subnet that's already configured on my VNet hub. And then we're going to go ahead next. I'm going to go back real fast. Like I mentioned earlier, your networking within your Azure environment might be a lot more complex, or should be a lot more complex than what I have. You're probably going to want your database servers segregated, your front-end servers segregated, using network security groups and things. So in this sense, you're probably going to want to hit configure later, because you're not going to want all 3 machines. Or you could come through here and repeat the step for each type of VM that you're going to be protecting. But for me, I'm just going to dump them all into the protection subnet that I've already created. Here is going to be a list of all the VMs that are going to be located on the Hyper-V server that I've installed the agent on, and then also it's going to be in the Hyper-V site. So if you had multiple Hyper-V servers, all your VMs should appear here. And since we're using the Waco DC, only the VMs on those Hyper-V servers should appear here. As I said, I'm going to replicate a domain controller and a domain controller. And for the fun of it, I'm going to replicate my management and my gateway, which my gateway is just basically the Windows Admin Center. Then we're going to click next. At this point, it's going to give us an option to what kind of OS is running on these, and what kind of OS disk, and if there's going to be other disks to replicate. So most of these are going to be, I mean, all these are Windows boxes at this point. I could have hit Windows and it should have defaulted. The OS disk for these are going to be um, Windows 2022, I think. I should probably go check and double check on those things because I was messing around with those VMs earlier. But anyway, and then over here is going to be if you're going to want to replicate multiple disks. So like, let's say you might have a SQL database, a SQL server that has, you know, 5 disks. You're gonna all those 5 disks you're gonna want to replicate. You hit next. This is going to be the replication policy that we've already configured. It's going to be that's already configured for that data center. We're going to click next. It gives us some reviews, and this is going to enable replication. So we're going to go to enable replication, and then we're just going to sit here, and I'm going to put the video on pause so you don't get to wait as long as I do. Okay, so we have our 4 machines, and the replication state is showing healthy, but the status still says 0 synchronized. At this step, it is going to take some time for the first initial synchronization to take place. I do have a nice little chart that I took off Microsoft Docs, and for basically this is kind of like a flow chart of how synchronization works. When you first enable synchronization, today my machines are not protected. We enabled protection. It prepared it for protection. So right now we're doing our start of our first initial synchronization here. It's going to synchronize. It's going to finalize the protection. At this point, the protected VM will be in a probably my VMs are slightly small, but I have a very slow network connection, internet connection. At this point, it's probably going to take a few hours, probably even longer, for my machines to actually show up as protected, and then ready for a test failover. Even at that, before you do a test failover, they're not surely going to be ready for a unplanned failover or even a planned failover, because we do need to go and do a test failover first to verify that the data is synced and ready. So I'm going to pause this video, and I will come back. For me, it'll be a few hours, and for the magic of the Christmas time, it'll be 1 second for you. Anyway, I will see you guys in 1 second. Okay, so welcome back. For you, about a second. For me, a lot longer than a second. So here we see now that our 4 VMs are now protected. We can see that the replication health is healthy. However, over here to the right, you see failover health is in a warning state. Don't freak out about this. This always happens. You have to do a test failover first to get that failover state into a healthy or ready status as well. So that's what we're going to do. We're going to do a test failover for each one of these protected items we have. And then once that's done, we could actually do our a disaster recovery drill and fail over to Azure, test everything, and then fail back down to Hyper-V. So let me go and open one of these protected items first of all here. We're going to click on our domain controller here. This is going to bring up the replicated items properties. Here we'll see the overview screen. It kind of gives us the health. It kind of gives us the reason why there's a warning. We could click on that, and we could tell that we've never completed a successful test failover. We get some of the basic information from this screen. Replication, which direction and how healthy it's going, how healthy everything is going. Up here along the top, we could do our planned failovers, our test failovers, some of the things we'll have to do later once we clean up a test failover or commit a failover. Things changing the recovery point. Let's say if you have multiple recovery points, we could change that, complete the migration, things like that we'll discuss during our actual disaster recovery drill that we're going to do here later. Over to the left is the properties for this device. It's going to basically tell you this protected item and your standard replication properties. This is the section that we would come to and make sure everything is correct before we do a planned failover. This is where you would change the switches and the targets that the switch is going to go to the proper networks. This is where you would tell it if you are eligible for Azure Hybrid benefits or if you actually want to register your a SQL VM uh, and things like that. Over here is where we could actually tell it to change the size of VMs once it spins up. We could tell it to change to the resource group, which we're going to be doing all this when we do a planned failover for disaster recovery here. But for this test failover, we're going to pretty much leave everything default. This shows the disks that are attached to this VM and if it's protected or not. This one only has a single disk. So let's go ahead and start our planned test failover on all 4 of our devices. So the biggest difference between a test failover and a planned or unplanned failover, of course, is with a test failover, we're going to target a segregated virtual network. So what's going to happen is in a normal failover, the system will actually shut down the VMs on-prem when it's ready to bring the VMs in Azure back up. If you do that and you have in a test failover, the test failover does not do that. So what's going to happen is you're going to have your data still running on-prem, and you're going to have a VM running in Azure. So if it's not in a protected, segregated VNet, you might have some issues with these machines, especially if you're you have a virtual gateway and your network is extended into Azure. Then you might have some DNS issues and a lot more issues with the same exact identity, same exact machine running in 2 different locations. Okay, I am going to be honest here. At this point, while recording this presentation, for some reason, my microphone on my headset got muted. And I did not realize that for about 25 minutes of recording. So instead of having to rebuild the environment or go back and redo the demos, I am just going to voice over the next 25 minutes of videos. So please forgive me and be patient with me. And I will continue on here, dubbing what I have already recorded, up to the point where I actually realized, hey, I don't have audio. Okay, so let's keep going. So I actually feel like I'm doing Mystery Science Theater. So at this point, we're going to configure our VMs, our protected items, because we're going to do a test failover here. We're going to go into the actual protected VM. We're going to go to compute network. We're going to edit, and we're going to change the resource group from the resource group default to where we're going to actually deploy the VMs for our test failover. Here we could configure size if we needed to. Here we could configure the virtual network if we needed to, but during the test failover, we don't really need to configure the target network because that will actually give us a choice. I do want to point out, as I'm pointing here, that I talked about managed disk. Using managed disk is only supported if you're going to fill up and never fill back. At this point, if you use managed disk, you cannot fill back to Hyper-V. That will change soon. They're going to be able to support that because, of course, non-managed disks are about to be end of life. I mentioned before, this is the virtual network that we could change to. We're not going to touch that now during the test failover. When we do a test failover, that's going to be possible during the wizard. We're going to save. It's going to date our configuration. And forgive me, I speak a lot, so I can't remember what I actually said here. So I'm just kind of assuming what I said. We're going to go back over to our protected items here. We're going to click on the context menu and we're going to do a test failover. This is going to be coming from our Waco DC, and it's going to be going to Azure, as you can see. We're going to select our test VNet because this is a segregated network. We're going to verify that we're not going to be deploying this test failover to a network that is peer to any other network or a network that has access to any other solutions. The recovery points are kind of important because you could choose recovery points based off time. Then we're going to go ahead and click Save, or actually click OK. And then the test failover is going to start here soon. As you can see the first box, our DC is initiating a test failover. If we click on that, it's going to take us to basically the job status. You're going to see that the test failover is starting. At this point, this is when it's going to start creating the VMs in that resource group that we created earlier and that we specified when we went to the computer properties. This will take some time. We could also go to the recovery demo test resource group that we created, and we can actually see the resources that are being created. As we see that there is a virtual machine being created. We see that a network interface is being created. There is a temp VNet that's going to be created, but then that is moved over to the actual temporary VNet that we actually called out. This is going to take some time, and I know in my original demo, as I talked, I would pause, let it catch up, come back, say something witty, say some kind of dad joke. Um, this is actually kind of strange, trying to narrate what I had already talked about in the past. So forgive me again. That's the first time I've ever done that. And I think at this point, I had put it on pause here soon, so you don't have to wait the 5-10 minutes that it's going to do this test failover. And as I said, magically, um, I did the test failover, and I initiated the test failover on the other three while it was on pause, so we could kind of speed this process up. The first one is completed, and the first one is actually now ready to do a planned failover, but we're going to be doing that here a little later. And once again, I totally forgot what I was talking about right here when I did this, so it's hard for me to fill in what I might have been rambling about. Right now, we're just waiting for the test failover to take place. And as you can see, we go back to the resource group where we're dumping our test failovers, and you can see that the other 3 VMs are being created. Along with a network interface. And the biggest reason we're going to be doing this, and we segregate, of course, we don't want to allow that segregated this traffic from these test machines to get out. And there's reasons for that. And I'm pretty sure I told you about that when I was on mute. And I'll cover that again here soon, here shortly. So, one of the reasons why we would probably, actually, one reason why you want to test failover to a segregated network is those machines are going to come up and they're going to be live. So you might have for instance, a domain controller that we're replicating, which we don't normally replicate domain controllers, because like I said in the past, you should already have these things already deployed in your Azure infrastructure. But for instance, you might have a SQL Server that comes up, and you have a SQL Server running already on-prem. So that same SQL Server is now going to be running in Azure. So if it was any VNet that was not segregated, you'll have some kind of you'll have traffic issues, um, DNS issues, because now they're going to fight for uh, which IP is actually the real IP of the server. Um, you know, other things, of course. So this is where I talked about recovery plans. Recovery plans is something that we're going to create. It enables us to take an entire application and fail over at one time. So like for my demo environment, we have, and I'll continue talking about this. My demo environment, we have a SQL backend, for instance. We have a front end, make believe front end, and a couple other VMs that we want to all um, to replicate at the same time. So what we're going to do here is we're going to name it, and we're going to enable the four VMs that are protected, and we're going to add this to this recovery plan. The source is Waco DC. The target is Azure, and we're not going to use Classic. We're going to use Resource Manager for the type. Classic is pretty much going to be gone soon. It's created the Waco DC demo app. We go in and customize this. Here you'll see that they're all grouped to one group. These are the machines that we're going to be creating, protecting and failing over. This is where we could separate them in three different groups, in fact. Um, for instance, the main controller we want to fail over first. Then we want the SQL server to fail over second, and then we want the two other servers, which would represent like our web application or the application servers, to fail over last. That way, the domain controller has time to spin up, the SQL server has time to spin up, um, and then the application server can come online, and all the services will be able to authenticate against the domain controller. I do not recommend using. I do not recommend failing over domain controllers. As I said, you should already have some kind of domain controllers running in Azure as a VM. If you do it that way with a gateway for replication between your on-prem solution and Azure. Um, SQL always on. There's other ways you could worry about your SQL always on solution. For one thing, you could always have a permanent SQL always on uh, cluster running in Azure that's being replicated across other SQL always on servers. So you don't have to worry about replicating if something failed, if your data center failed. So here, I'm going to add two more groups, as I mentioned before. We're going to remove from group one. We're going to remove the three VMs: the SQL server, the management server, and the gateway server from group one by clicking on the three dots on the right and remove. Then we're going to go into group two and we're going to add a protected item. This one's going to be our SQL server. Click OK here. And then group three, we're going to add our make-believe app servers, application servers. Here at this point, um, we could add pre-actions or post-actions. And these are the kind of actions like we could add SQL, we could add PowerShell scripts, we could add Azure runbooks, Azure automation runbooks to these solutions. For one thing, is for instance, your SQL server when a cluster is going to migrate, the only IP address that's going to change that ASR is going to be able to change is the VM IP address. So you still have IP addresses that exist in the cluster itself. So that needs to be taken care of. And you could do that. I could automate those changes using my brain's went dead, using Azure Automation Runbooks. There's actually some templates out there for that, and You might have other things you might need to name. You might need to rename some resources when they move up. We're going to save it. Now, as you can see, our failover is successful. At this point, you should have tested the machines and make sure that they work. You can see that the machines exist in the resource group that we created for this test failover, the four NICs. The next step is to clean up the test failover, clean up the failover test. That's fairly easy. Just go over, click on the things, clean up, type in some fancy notes, check back the box, click OK. That's gonna basically clean up those resources and get the system ready to for a planned failover that we're going to do here soon, shortly. I don't know if you guys ever try to narrate your own work, but I'm going to be honest with you. This is extremely difficult because I don't even remember what I did. So this is why I think this is like a great episode of Mystery Science Theater. I think 2000. I don't know if you young folks remember what that show is about, but yeah, for your older guys like me, you know exactly what I'm talking about here. So now we're ready. We have no failover health is healthy. Our revocation health is healthy. Our four VMs are actually ready now to do a planned failover. That's pretty exciting. This is what we've been waiting for. This is what we built this everything up to. The suspense. We are ready to do our planned failover from Hyper-V to Azure. Exciting. And I'm still kind of curious what I was talking about here. I'm still curious what I was talking about here. Still curious. Sorry, guys. I am very, very sorry. I wish I would have paid attention and QA'd some of my recordings a little more advanced. Because I was giving some good advice here. I know I was. I just forgot and left the recording while I went and got like a iced tea or something. Who knows? Okay, so I'm pretty sure I put you on pause for some reason, and I unpaused you here. And I was talking about how excited I was to actually do a plan failover. And there's some configurations that we need to do to each one of these protected items before we go. And I would discuss a little more about what we could change inside that inside the properties of each one of these protected items. All right, look at that. So let's go ahead and click on our domain controller and go to compute and network. And as you can see, that was the resource group that we dumped our test into. So we're going to hit edit, and we're going to actually change this to a production resource group called Waco ASR South Central US region, if I could find it. There I am. Look at that. Click on there. Yes. We're going to use that. That's our production environment, or representing our production environment. We're talking about renaming if we need to rename the device. We're actually talking about size here. Um, we're going to hit save just to save this configuration. I went in and talked a little bit about the virtual network and the target network. And then we did that for each one. I went in and edited the compute network, making sure that the resource group was configured correctly. Hit edit here, of course. Change the resource group to the proper production resource group. Then the management, did the same thing there. I talked about some of the disk and making sure that the disk were going to be protected. Just double checking everything, making sure that everything's configured correctly. We're going to click back on computer network, hit edit, and change the resource group again to the correct resource group. Now, if you had multiple resource groups, you could, for some reason, you might have split these resources up. The sizing is something that we want to talk about a little bit. ASR does its own little adjustment suggestions of what the sizing should be. If you need a larger VM, specifically for like SQL, this is where you're going to change it from a B to maybe a larger D SKU, giving you a little more memory, giving you a little more cores. We don't have any availability sets. We talked about managed disk, making sure that if you're going to fill up and fill back down, we're not going to use managed disk. Proximity placement groups, we'll talk about a little later in this demo. I'll just go to mention what they are. Proximity placement groups at a high level are if you want to replicate a machine, right now you're replicating to South Central, but let's say you want to replicate to another resource, another region. This enables you to not only to target another region using proximity placement groups, and then tagging. I think I talked about. I think I clicked on it and um, talked a little about tags, and I think they failed because we're not using the proper storage or something. And we'll find that out here soon enough. But with tags, it doesn't really matter because with tags, we could use an Azure policy, which I talk about a little later. But I use this as my favorite quote. You're a wizard, Harry. I also mentioned that if my good friend Kenny Lowe was on, he would hopefully get a kick out of that one because there's many times we're at Universal Studios during Ignite, and I'd always look at him and say, "You're a wizard, Harry." But oh, because they're not managed disk, we can't tag. But that's okay. We use Azure policy, and we get force tags on things. Also went into the virtual network and discussed how to actually assign a static IP address versus a DHCP address. I also talked about Azure Hybrid Benefits here. If you are Azure Hybrid Benefit, being able to click on yes, you kind of confirm the eligibility of your Windows license. Since this is Christmas, we want to be honest. We don't want coal in our stockings, so make sure that if you aren't Hybrid Benefit enabled, that you don't select yes. RP, enabling that allows you to take advantage of automated patching and automated backup and more simplified license management using the SQL VM RP. This also enables you to either pay as you go or use hybrid benefits. I don't have either, so I hit no, and I don't want coal in my stocking, so I hit no. But if you did have Azure hybrid benefits, this is where you'd really want to take advantage of it. At this point, I should have been talking about networking here. How to if you click on the network interfaces, if you had multiple network interfaces, you'd be able to select them here, tell which one's going to be primary, which one's going to be secondary, etc., etc. And then I clicked on set switch here, and this is where we could tell it which subnet we want to use if we had multiple subnets in that VNet, which we do. But this is our production set subnet. And this is our private IP address. It's going to assign a dynamic IP address of that 10.1.3 range. But if we had a static IP address that we had to use, This is where we would add a static IP address and then hit OK. And then that would give the VM that specific static IP address within that subnet. There's various reasons. For one thing is, especially SQL, you might have static IP addresses that machine needs to speak. You might have network security groups that are by IP address, things like that. Verify that everything is good to go here. This is where I talked a little bit about proximity groups, I think, of course. Kind of jumped the gun earlier. We hit save. It takes a few minutes to save that configuration. And I actually think I forgot to edit. No, I did all three. Okay, good. Once this is done, then we could actually move forward with our planned failover. I'm excited, aren't you? Yes. Okay. So here we're actually going to finally start our planned failover. We're going to go to our recovery plan. We're going to click on it. We're going to go to customize. So we just want to view it, make sure that everything's correct. Make sure that our groups are in order, the right resources are there, the protected items are in the right groups to shut down first and to start first, vice versa, all that fun stuff. We're going to hit plan failover. Actually, we're going to go to the Hyper-V server first and verify that the replication health is normal, the machines look normal, there's no errors. And then we're going to go back over to the portal. And we're going to do a plan failover. At this point, it throws an error message, which is kind of strange for me because I did a test failover. If we go to the actual individual protected items and hit plan failover, I don't get this error message. So I'm just going to go ahead and skip it because we do know that we did a test failover because I have it on video. So I have proof that we did it. Just go ahead and click that button. See, I'm telling myself. The failover direction is Waco, DC to Microsoft Azure. We can hit change direction here, but we really don't need to. And we can't anyway because, of course, nothing is in Azure right now. It's all on Hyper-V. So I'm going to move the mouse a little bit around and then hit OK. And that's going to kick off. And of course, once this kicks off, then there's a few different errors. I got this and I don't really understand why, but I magically fixed it without you guys seeing me. Look at that. Boom. I'm awesome. So we're going to come in and I'm going to show you a couple different ways you can get to the job to see the status of what the job is doing here. Of course, we could click on plan failover in progress there, or we could actually go down to monitoring on the left and go to site recovery jobs. Site recovery jobs, and then hit in progress. And that's going to bring us to the job, and it's going to show us what's the status, where we're at, what's running. Of course, it's going to shut down the devices. It's going to recover, bring up the VMs, and it's going to do it in this order. And through the magic of Christmas video, in about 10 seconds, this is going to be done. Probably a little more than 10 seconds. But so you guys don't have to put up with the long journey. It should be done here fairly shortly because I ran out of things to talk about until my next segment here. Yep, magic. Look at that. What? And in about 2 seconds, even more magic. Well, a little longer than 2 seconds. Okay, so this is the point where my audio actually was working. So from this point on, it's going to be me talking as I'm actually doing it, not me dubbing what I was doing. So here we have a plan failover where we left off. But when we left off, of course, it was in the middle of doing the plan failover. At this point, as you can see, the plan failover has been successful. We could go and uh, go into the resource groups for our production environment that we failed over, and we can see that our 4 VMs are up and running with the 4 NICs. Then we can click in here to our domain controller. We can see that the IP address is here. The one thing I do want to call out, though, is in a production environment, as I mentioned before, you're most likely not going to be replicating a domain controller to Azure. More than likely, you already have a presence in Azure. You already have your Active Directory domain in running on a VM within Azure, and that is being replicated to your on-prem Active Directory via either some kind of gateway solution you got or express route, something. So in this case, the only thing you would probably need to do at this point is making sure that the VNet that we're attached to has the proper DNS, has the proper DNS settings. So not using Azure DNS, you're using your own DNS. That way, these machines that pop up there will be able to resolve everything and authenticate against the your current Active Directory identity. Another thing I want to call out too is because these machines don't have public IP addresses out of the box when you just do this failover, everything's going to be a private IP address. So that's also a reason why I have enabled Bastion on my VNet that the subnet is attached to. So I could just use Bastion to jump onto these machines at this point. It's the most secure way, for one thing, doing these things. Or you could have had a pre-deployed jump server deployed that's connected to the same VNet or a VNet that is peered, and then you should be able to jump over to this machine with the private IP. Or you could just add a public IP if you wanted to, but if you want to stick with best practices and stuff, I'd advise not to put public IP addresses on VMs. So there's a few things we want to do first before we consider successful failover. We do want to get on at least the domain controller or the SQL server. We want to make sure that the services have started, that the machines are talking to each other. In a production failover, you might have other data centers, making sure that these machines might be able to communicate to those other data centers depending on how you have your routing configured. And most likely, you have that capability to speak to other data centers if you have multiple data centers and you're just failing over one data center for this planned failover. And making sure the applications can communicate between on-prem and on-prem and in the cloud, and making sure users could actually get on as well before we consider this as a successful failover. There is one final step that we need to take in order to finalize this failover, and that's actually commit this failover. To do so, we're going to go back to our recovery vault. We can actually do this from our site recovery plan that we created earlier and that we actually ran. We can either go to the 3 little icon Eclipse things that we call, I don't know what they call them, and hit commit, or we could go into the plan itself and there should be a commit at the top. What this is basically going to do is it's going to commit the changes and it's going to delete all the available recovery points at this point. So we're going to go ahead and hit commit. Since this is my recovery plan, when I commit here, it's going to actually commit on all 4 protected items that we had. We're going to hit commit. It's going to ask you, are you sure you want to commit? You can hit OK. And that commit starts. And within a minute or two, it should be completed here. So once these have been committed, these machines are actually now live in Azure. There's a lot of things that we need to do in order to truly have a true BCDR solution and to truly protect these machines. Just because these machines are now running in Azure, it does not make them highly available or resilient in the sense that if this data center in Azure, this zone goes down, or these VMs go down, you're still not protected. There's other things we could talk about. Talking about using Azure to Azure ASR. So if this region for some reason goes down, your VM machine, your Azure VMs that are protected will then basically fail over to another Azure region. We're also going to talk about Azure Backup because we do need to make sure those machines, as long as they reside in Azure or even on-prem, are being backed up by Azure Backup. That way, if you have any issues where you just need to do some file-level restores or even restore the VM itself, um, that will save your bacon and save your Christmas ham as well. But for now, what we need to do is, after failover, we need to reprotect these Azure VMs, no matter what we do, even if we're going to replicate them to Azure, or, but in this demo, we're actually going to re-replicate them. We're going to replicate these machines on-prem to prove that we could fail to Azure and then fail back. So we're going to reprotect these Azure VMs so that they replicate from Azure to on-prem, kind of like we did earlier, where we enabled protection from on-prem to Azure. That way, we could fall back, and that's going to be our next process here. Okay, so outside of committing the failover, there's two other options that we could choose when we have the when the failover is complete. You could come in here and you can complete the migration. That will basically um, make the machine permanently in Azure. You will not be able to fill that machine back to either Hyper-V or VMM at that point. That solution is nice if you're just gonna if you're using ASR to do migrations. You can also disable the replication as well, which we don't really want to do because we want to make sure that these machines are being replicated back to Azure once you commit it. I mean, not Azure. You're being replicated back to Hyper-V once we commit them. That way, we could do another plan failover and fill them over back to Hyper-V and have them run on-prem. So we're ready to do another failback, plan failover, but this time we're going to fail back to Hyper-V. We've tested the machines. We could log into our SQL server. We could log into our domain controller. Everything seems to work. The imaginary application is working. Users could access it. It's been running for, let's say, a month now, hypothetically. But we want to fail over. Actually, it's not been running for a month because this is a planned failover. So it's been running for a day or two, let's just say, and then we're going to, or even a few hours, like we've got it running for a few hours here. But anyway, we're going to fail back over to Hyper-V, and that's the whole point. So it's fairly the same process as we did when we failed up. There's a couple different decisions that we got to make, but we're going to go back to our site recovery infrastructure, site recovery service vault, and then under recovery plans, we're going to click on our Waco DC, and we're going to do a plan failover again. This time we cannot go from Waco to Azure. It's only available from Azure to Waco. We could change directions if we want, or we could actually change the site that it's going to outside of just filling back over to the original site. This is what is going to be kind of important here. So we have two options here: minimize downtime or full download. Minimizing the downtime means that you want the VM in Azure up and running as long as you can before we make that cut over to spin that machine up and Hyper-V back up. This does take a little longer at times because it's actually not only replicating the data back to Azure, back to your on-prem location, but it's also constantly trying to do checksums on the data that's changing. So if you're really needing availability of these VMs, this is the one you're going to do. This is going to minimize your downtime. The second one is a full download. This one basically will you don't have to worry about you know the data's changed. You don't have to you want to get that VM on-prem as fast as possible, and you don't care about minimizing downtime. You would do a full download. It's going to shut down the VM in Azure, and then it's going to start doing its sync immediately to Hyper-V, and then spin the machine up. In most cases, if you're in a production environment or you really care about maximizing your downtime, we're going to maximizing your uptime, not your downtime. We're going to go ahead and choose minimize downtime. This last option here is, let's say that you did somehow the VM got destroyed on-prem. You can click on that button, that check mark, and the VM on-prem will actually be created if it does not exist anymore. But we already have our VMs on-prem, and at this point we're just going to go ahead and click OK. And just like before, the plan failover is going to run. We can go and watch it. You'll be able to see the data synchronization going. This is going to take a lot longer than what we had coming up, in the fact that the data has to synchronize and the changes have to synchronize. So you have a machine that's getting hit, like a SQL server that's always getting hit constantly. That SQL server may take a lot longer to replicate down. The good news is it's going to be up, and it's not going to shut itself down and switch back to Hyper-V until the last possible second when that data has been synchronized. Again, the same thing comes into play where you've got to worry about DNS, because once that machine shuts down Azure, comes up in on-prem, it's going to return back to the original IP address. So the DNS needs to be, propagate and refresh. If you have any load balancing, things like that. We can also do some automation again using Azure automation and some runbooks to do some of these features for us. If we had like a load balancer, like Azure Traffic Manager, things like that could be automated to switch the traffic from going to Azure back to your on-prem solution. There is one thing that we did not have to do when we failed up. Once that data has been synchronized, it is going to prompt for user input, and basically it's going to prompt for you to continue. When that data has been synchronized and it's ready to do the failover and shutdown, it will prompt you. So you do have to kind of be aware and be watching this. Otherwise, this might just sit there all night or until the user accepts it. So at this point, I'm just going to put this on pause, and we're going to come back to the point where it's actually waiting for user input. For you, it's going to be a few seconds. For me, well, who knows? I am on a very slow connection, and it might take a few hours. Okay, I will see you in 1 second. So it's not done yet, but I did want to point out one thing. If we go to a Hyper-V server and we open up the Hyper-V manager, we can actually see the status, the fallback replication status of each one of these machines and the percentage that it's on. So if you wanted to get like a better viewpoint and know when or where these machines are, what their percentage is, you can come down here and kind of view the fallback replication, and then also see if there's any errors as well ahead of time. But this is a good location to be monitoring and watching. As you can see, mine is only about 14% for the smaller boxes and only 5% for the bigger boxes. So this may take some time. So I guess we just put you back on pause, and I'll see you in a second again. Okay, so the initial data synchronization is done, and now we basically are at the point where it's going to prompt us for the user input required. Pretty simple. Just kind of go up here and then click complete failover. This is where it's going to shut down the Azure VM, the Azure VMs in order, and then it's going to then fail over those VMs, and then it's going to start the domain controller, then start the SQL server, and then start our last two boxes on our Hyper-V box here. And they are just waiting for us. So let's go ahead and click complete failover. Yes, I'm sure. Operations in progress, and at this point, this basically looks exactly like we did when we filled over to Azure. Um, so we'll just, I'm going to put you on pause, and I'll be back in a few seconds for you. See you soon. Okay, so we have actually successfully filled back over to Hyper-V. And just like filling up to Azure, there's a few things that we need to do in order to commit this failover and to also re-enable the replication back to Azure to keep these machines protected. First thing we're going to do is we're going to go back to our site recovery plan. We see that the plan failover completed. We're going to come back down to here, and we're to our little three dots, and we're going to hit commit. It's going to ask us, are you sure? We're going to hit OK, and it takes a few minutes for it to commit. And I'll put you on pause, and I'll be right back. So we've committed, and the commitment is complete. When you do the commitment, or when we click on commit, basically in the background, the commit deletes the Azure VMs and its disk that we created earlier when we filled up to Azure, and then it prepares the on-premise VMs to be protected again. When we click, the next item we're going to click is the reverse replication or reverse replicate. That is going to enable the replication of the on-premise VMs back to Azure. The only thing that's going to actually change is the delta changes, since the VM was turned on, and basically uh, the VM is running and the VM is up to date. So the only thing now that's going to be replicated up to Azure are the delta changes. Once we hit reverse replicate, let's go look how the replicated items under protected items look before we do that reverse replicate. You'll see that all four of our machines are healthy. All four of them have fallback finalized, but the failover health is still not there because we have not issued the command to replicate the data back up. So to do this easily, since we have these as a recovery plan, we'll just go back to our recovery plan. We're going to click on the little dots, and then we're going to hit reverse replicate. Reverse replicate will protect our machines and then send the data back up to Azure. We'll click OK. This is going to take a few minutes, and then everything should look fine and dandy. And we should be ready to do another fallback if we need to. But we're going to go and discuss some more advanced topics or some things that you should be considering. What you should do to continue protecting these VMs outside of ASR, and how to automate some of those things using like Azure Policy and things like that. Let's check out the status really fast. As you can see, our four machines, of course, replication health is healthy. Three of them, the failover health is now healthy. The first one is still waiting for the first recovery point. Just to show you what it looks like on Hyper-V, you can see that it still replicated the initial changes back up to Azure. So when this is 100%, we should see that this failover health is going to be healthy. And then we know that our four VMs are now protected again, and we could know and feel safe that if we do have a major disaster at a data center or at an office site location, that these machines will be protected by Azure Site Recovery, and that we could fill them over within about 5 or 10 minutes time period, sometimes a little longer, and have those applications and stuff running in Azure, and with a little bit of downtime. Okay, so we are done. The machines are now protected, and they are now syncing back up to Azure. As you can see, they're all healthy, and they're all ready to basically go and move forward with using Azure Site Recovery to protect these four machines. So we have successfully failed over. Actually, let's start from the beginning. So we configured a recovery service vault, and we enabled and protected some VMs on a on-prem Hyper-V server. Then we did some test failovers to verify that the test failover is going to work. Then we did a planned failover from Hyper-V to Azure, tested our machines, verified that they worked. Then we fell back down to Hyper-V, and that's where we're pretty much at this point. All our machines are now protected, um, and they are being replicated to Azure. So if we need to do another planned failover, or if something disaster happens, we're in a good spot to where these machines will be protected, which means our Christmas ham and our bacon and our jobs should be protected too. But there's a few more things we want to talk about before I end this session um, on Azure Site Recovery. We want to talk a little bit about Azure Backup, um, and I also want to talk about some of the automation tools we could use to help automate um, or to better help you be successful with your BCDR, your planning, not just with ASR, but with Azure Backup and all the other needs that need to come in to help make sure that your VMs are secure, including update management, things like that. First thing I want to discuss, just at a high level, is Windows Admin Center, and being able to use Windows Admin Center to be able to enable replication on VMs and also to uh, enable Azure Arc for servers and also to enable Azure Backup as well. All from Windows Admin Center, managing servers in a hybrid environment on-prem and multi-cloud as well, but we're going to focus on on-prem here. We're not going to go too much into detail. I just kind of want to show you that whenever you come over to Hyper-V here, Hyper-V is being managed by Windows Admin Center on my on-prem solution here. We go down to virtual machines, and we see our virtual machines here once it loads. It takes a few seconds here. We'll click on any of these virtual machines for now. Then we'll come up to manage, and then we can enable replication. As you can see, it's already been configured. We know that we're using this subscription. This is going to target South Central US. We're going to also target, this is going to be the recovery service fault that we're going to target. And then we're going to pretty much use an existing storage account. Then we're going to hit protect VM. And then that is going to configure and enable protection on that VM. And then we should be able to see that VM in the Azure portal now as a protected VM. Another thing with Azure Site Recovery, not Azure Site Recovery, another thing with Windows Admin Center is being able to enable Azure Backup. Fairly easy for your on-prem systems. Just clicking on setting up backup, making sure that the drives that you want to backup are selected, making sure that you're logged into the right accounts, and there's some other various things that we want to configure to enable backup from Windows Admin Center. These are nice tools, but they're more for like one-offs, I would say. If you have a whole bunch of machines, there's a lot easier way that we can automate all this stuff, and that's what we're going to talk about here shortly. So now I want to talk a little bit what we could do for automating and helping you out, making sure that your BCDR solution is 100%. We have Azure Site Recovery configured. But what happens if those machines do fail over to Azure? How are we going to get Azure Backup enabled? How do we get machines that are brand new in your environment to automatically have not only Azure Backup enabled, but what about Azure Site Recovery? These machines have failed over to Azure. That's nice that you protected yourself from a, a disaster at your data center, but are they protected still at this point, just sitting in Azure? Um, there are some protections in place, that we could talk about, but what we really want to do is be able to automate the enablement of Azure Backup for any machine that comes into Azure. Also, enable Azure Backup for any machine that is deployed to Hyper-V, and to that you want that. Anyway, I'm tongue twisted here. We also want to talk about enabling the site recovery automatically as well. So there's different ways we could do this. Actually, there's one way that we could do this, and it all becomes Azure Arc. So when we have Azure Arc for servers deployed and managed, this will enable us to use Azure policy on those Azure Arc resources at this point. There's some policies that come from Azure Backup Center that are very, very, very useful. If you've ever used Azure Backup Center, this is the new backup center for Azure Backup. Under policy compliance, there's some Azure policies for backup that are predefined. Um, to be able to enable any Azure VM for Azure Backup, to be able to enable any Azure Arc VM for Azure Backup. We also want to we could also specify which recovery vault those Azure VMs are going to be backed up to based off of regions and tags and things like that. That way, if any Azure VM is deployed in your environment, those VMs will automatically be um, compliant and be backed up. Um, we also have some policies that we can enable to enable Azure Site Recovery. So once an Azure VM, once a VM appears in Azure, if it's been failed over from on-prem solution, that solution can then be configured to enable Azure to Azure Site Recovery as well. So you get that added benefit of if for by any means, by any chance, that an Microsoft Azure Data Center, an entire region goes down, um, those VMs can be protected and replicate to another region. And this can all be automated using Azure policies. Um, this whole area is in alone in itself another session, and I just wanted to kind of go high level over that, giving you the option and letting you know some of the automation tools that are available out there. There's one more thing I'd like to just hit on for like 30 seconds, and it's in preview, and it's called Azure Automate or Azure Automation or Azure. Sorry, tongue twisted. Azure Auto Manage. This is actually a kind of a cool little solution that you enable, and this auto manages any of your Azure VMs, even Azure Arc for server resources. It could be targeted for resource group. It could be targeted for pure subscription. It could be targeted for management group as well. And what does that? I mean, what does Automatic actually do for those? So basically, you click on it, you enable it, and it gives you the capabilities to auto-configure machine insights for monitoring, Azure Backup. It enables Microsoft Defender for Cloud, update management, the new update management that is in preview, change tracking, machine configuration, boot diagnostics, a whole slew of different Azure services that automatically get managed on the back end. You enable it, and it's pretty much done. There's some configurations you have to do if you want to do that you could that you probably want to do, so you could kind of tell it which backup vault to go to, which log analytics workspace to write to. But those are usually just one-time things. But if you're really looking into a nice little solution that will enable you to manage your Azure VMs and manage your Azure Arc servers um, automatically, I would actually look into Azure Auto Manage as well. So once again, my name is Kristopher Turner. I hope this presentation on Azure Site Recovery was helpful. I hope in the future it will save your Christmas ham, it will save your bacon, but most of all that it will save your job. I want to thank you, and I want to be one of the first ones to wish you a happy New Year's. So I hope your New Year is going to be blessed, and I look forward to talking to you about Azure Site Recovery. Thank you, and have a good night.